On the following sub-question, we were instructed to pick one of these collisions and justify our selection by calculation. So, we will justify by calculating kinetic energy before and after. A kinetic energy after collision is the same with kinetic energy before collision. That means the collision is an elastic collision. But if kinetic energy before is not equal to kinetic after collision, that means this collision is an inelastic collision. Without wasting time, the total kinetic energy before collision is made up from the kinetic energy of the bullet, plus the kinetic energy of the block. Note: this kinetic energy of wooden block is zero because the velocity is zero. By doing so, we get total kinetic energy before collision is 1,000 joules. Then the total kinetic energy after collision, we combine masses to be 0.2 kilogram, and use this final velocity that we got from above question. We get the total kinetic energy after collision to be 250 joules. So, the total kinetic energy before is not equal with total kinetic energy after collision. Therefore, the collision is an inelastic collision. On this last sub-question, we are told that now the bullet is fired with the same velocity close to the block, but now the bullet goes through the block exit the other side with 195 meters per second. From this statement, we were instructed to calculate the time the bullet took to exist on the other side of the block. Please take note that the net force is given and is said to be downwards, which means it is negative. On this question, we use the impulse formula where we leave the time as the subject of the formula. Change in momentum of the bullet is momentum before it hits the block minus the momentum after collision, all divided by net force. We get this time, which is measured in seconds. For the sake of practice, please try these questions. Then check answers which are provided already.